Hello everyone. Let me move this screen over to this side first so it doesn't block our way. Okay, I think this should do it. Right. We have come to another topic which is called the electrical resistance, and we shall begin without further ado. All right. With regards to this particular chapter, we are referring to a resistance. A resistance here means an opposition, right? It wants to oppose something. And what does it want to oppose? Two things. It wants to oppose not only just the current, but also the voltage itself, right? So the three components of the Ohm's law in this case here would be the voltage, the current, and also the resistance. V stands for voltage, I stands for current, and in this case here, I actually stands for intensity, and it's actually from a French word, intensite, right? The resistance here is represented by R, and we want to see how Ohm's law here relates both resistance with its voltage and also current. This is Ohm's law, where you have a triangle, and this triangle here separates the voltage, the current, and also the resistance. So V, of course, represents your voltage, I represents your current, and R represents your resistance, right? So if we rearrange this equation, you can get V equals to IR if I cover my V. If I cover my I will get V over R. If I cover my R, I will get V over I. So take the time to sit down and digest. Resistance here is basically a property where you try to oppose something. In this case here, for any electrical conductors, you are actually opposing the flow of electrons. Remember in our previous session, we mentioned that the electrons are moving electrical charges throughout the circuit. So resistance here is trying to oppose how much these electrons will flow through. It's measured in ohms, and the symbol is the omega. And therefore, when you speak about conductors and also insulators, we have spoken about conductors and insulators in our previous chapter on heating and cooling. So we do know that conductors are good materials that are able to conduct heat or electricity. But basically, another definition is that it has low resistance, right? Low resistance here means low opposition. A low opposition here means that the electrons will be able to flow more. So therefore, conductors are able to allow more electrons to flow to carry more heat and also carry the electrical charges. And the opposite holds true for materials that provide high resistance. And of course, if you have guessed, they are known as your insulators. There are three factors that your resistance will depend on: the type of material, as we've mentioned, a conductor or an insulator, or a conductor and a better conductor. The second point here would be the thickness of the wire. So notice that this wire here is thick and this wire here is thin. Why not if we take the opportunity to search whether the thicker the wire, the higher the resistance, or the opposite? I challenge you to that. And my last point over here, let me move this aside, right, is the length of wire. So of course here, if you can see, the length of the wire would be short, right, based on the pointer that I'm pointing at, and it will be longer on the bottom section here. So we will have to take into consideration which one here has a higher resistance. So if we look at the short length wire, you definitely know there will be low resistance because the distance it takes to travel from the beginning to the end here is rather short, right? Whereas as compared to the longer one, you will get from the beginning to the end here, which is a little bit longer. So your resistance would be much higher, right? So this here is basically the end for the presentation. It's only just 5 slides, but the real calculations come in the notes section. I hope that you enjoyed this session, and don't forget to replay this again if you are not sure, all right, of certain concepts. And best of all, if you're in class, do come and see me.